Good morning, students. Welcome to our lesson for today. In this lesson, we will draw and interpret simple line graphs for time series. We will be using the keywords line graph and trend. In drawing line graphs, it's always convenient to use x-axis for time and y-axis for the data. Remember, the x-axis is the independent variable and time is an independent variable. So for this example, the table shows the daily temperature for New York City recorded for 6 days in degrees Fahrenheit. So let's draw a line graph for the data. So the x-axis is the days and the y-axis will be the degrees Fahrenheit. So for the first day, day 1, temperature is 43. So that gives us the point 1, 43. Day 2 is 53 degrees. So 2, 53. So plot that point. Next, day 3, 50. Plot it. Day 4, 57. Day 5, 59. And day 6, 67. Now, connect these points and we have the line graph. So this is what we call a trend. So if we describe this trend, we say that the temperature has increased over the 6 days. So only a decrease is from day 2 to day 3. So it's always increasing. So we say here that the trend is increasing. Try this example on a graph paper. Pause this video and continue when you are done to check your work. Let's check your work. So we have here a table of Sarah's car value over the years. So the first one, 2001, 24,000. 2002, 22,500. So if we plot these points year on the x-axis and the value of the car in the y-axis, we will have this graph. And how do we describe this trend? It is a decreasing trend. So we say that value of Sarah's car has decreased over the years. So let's try the answers to these questions. The title of the line graph, the value of Sarah's car. Range of values on the horizontal scale, that would be the years, it's 2001 to 2007. Range of values on the vertical scale, that's the amount of money. So we will start with 0, the highest is 24,000. So it is safe to write the scale in 5,000, so that would be 0 to 25,000. How many points are there in the graph? There are 7 values, so there should be 7 points. And the highest value recorded is $24,000. What is the lowest value recorded? That would be $5,800. And did the value increase or decrease over time? Then we see, just looking at the graph, the trend is decreasing. So it never increased. So the value of the car is always decreasing. Here is another example. Try it on your graph paper. Pause this video and continue when you are done to check your work. Let's check your work. So in the x-axis, we should have the time in months. And on the y-axis is the weight of Sam in each month. Okay? So if you will plot the points January 49, February is 54 kilograms, March is 61, we will have this line graph. So this trend, as we described, we see it is increasing. So this means that Sam's weight has increased as the months have gone on. So as time goes by, Sam is gaining weight. So let's read the essentials of this graph, starting from the title. Title is Sam's weight. What is the range of values in the horizontal scale? That would be the months in January to May. The range of values in the vertical scale. The highest recorded weight is 73, so it is safe to write 0 to 80. Now, how many points in the graph? There are 5 recorded weights, so there will be 5 points. What is the highest value recorded is 73, as I have said, and the lowest value recorded is in January, that's 49 kilograms. Did some weight increase or decrease over time? It's always increasing, so it increases over time. It increases every month. Let's interpret this line graph. So as the title says, people in a store. So they recorded the number of people in a store from 10 a.m. to 6 p.m. The time is indicated in the x-axis. So like for example, at 10 a.m. they have 2 people. At 11 a.m. they have 5 people. So that's the y-axis as the number of people. So let's answer some questions. What is the line graph about? So as the title says, it's the people in a store. The busiest time of the day at the store, that would be the highest point on the graph, that is at 1 p.m. the busiest time. What time does the business start to slow down? Slow down means there's not much activity in the store anymore, not much change, so it's at 3 p.m. because as you see at 3 p.m. there are only 5, and then 4 p.m. is 4, and then 5 p.m. is 4. So that means there is not much activity in this store anymore. So it slows down its operation. How many people are in the store when it opened? It opened at 10 a.m. That's the first point on the graph. So at 10 a.m. there are 2 people. About how many people are in the store at 2:30 p.m. At 2:30 p.m. look at the point between 2 p.m. and 3 p.m. and that's where you have 11 people. What was the greatest number of people in the store? So you look at the highest point again, and it says as the number of people that is in the y-axis, so that would be 22 people. What was the least number of people in the store? That would be the lowest point of the graph, and that's actually the beginning, which is 2 people. Second highest is in the evening when they're about to close maybe, and that's 3 people. But the smallest is 2 people. That's the least number of people in the store. Let's try this another example. It's a small town teens with cell phones. Now, the x-axis is the age in years, and the y-axis tells us the number of teens with cell phone. So the line graph is about small town teens with cell phones, and teens have the greatest number of cell phones at age, so that would be the highest point, that's at 19 years. Teens have the least number of cell phones, that would be the lowest point on the graph, and that's 13 years. The 13 years old. 15-year-olds have, so that to look at the 15 on the x-axis and go up, that gives us 341 cell phones. 16-and-a-half-year-old teens have about, so 16-and-a-half is between 16 and 17, and that is approximately about 500 cell phones. That's a good estimate. The greatest number of cell phones at any age is, so this is now number of cell phones, so look at the y-axis, and the highest point, that gives us 642 cell phones. The least number of cell phones at any age is, so that's the lowest point, how many cell phones? That's about 229 cell phones. As the teen gets older, so this is now describing the trend. as the teens get older, do they have cell phone, or do we have a decrease in the number of cell phone? They tend to own a cell phone because the number of teens owning a cell phone as the age increases is increasing also. So the trend is increasing. It only decreases from the age 17 to 18. There are less teens owning a cell phone that are 18 years old than 17 years old. So it's like telling us that at 17 they get a cell phone, at 18 it was confiscated, maybe because they are doing something with it. Now do this on a graph paper. Pause this video and come back when you are done to check your work. Let's check your work. So we have to draw a time series graph for this table. So you have the quarters on the x-axis, the electrical units on the y-axis, so you should have this kind of graph. So I want you to observe and compare the trend for each year. So year 2000 is from quarter 1 to 2 to 3 to 4 to 5. What is happening on that? So 1 to 2 increase, 2 to 3 is a big decrease, 3 to 4 increase, 4 to 5 decrease. Now look at the trend in 2001 from quarter 5 to 6 to 7 to 8 to 9. So it increased from 5 to 6, decrease, increase, decrease, increase. Now look at the trend in 2002. That is starting from quarter 9 to 12. So from 9 to 10 to 11 to 12. So if you see what is happening for each quarter now. So 2001, compare 1 to 2 to 5 to 6 in 2001 and quarter 9 to 10 in 2002. What do you notice? Yes. So basically these 3 years have the same trend. So for example, in each first quarter, they're all increasing. 1 to 2, 5 to 6, 9 to 10, they're increasing. In the second quarter, they will have a big decrease. 2 to 3 is decreasing, 6 to 7 is decreasing, and then 10 to 11 decreases. And on the third quarter, 3 to 4 again increase in 2000. That would be 7 to 8 in 2000, it's also increasing, and 11 to 12 is also increasing for 2002. So if you see, this is like a repeating trend for each year, and also the point does not vary too much. So this is close to what we call a constant trend or a repeating trend.